Okay, now we are going to prove the sum and difference identity. If you remember from previous proofs, we leave the most simple side alone. So this right here is the start of the problem. This is the end. They want me to fill in the work in between. That's how you should think of it, okay? So this is sine, so I'm going to use the sine formula. What should I write on my paper? Sine pi cosine x minus cosine pi sine x. Okay? Pi is worth how many degrees? 180. Okay? 180 is exactly right there. Yes? Okay. Remember that sine is y, cosine is x. What is the y value at 180? It is 0. Excellent. So 0 times the cosine of x minus, what is the x value? It is negative 1 sine x. So now we have 0 minus a negative sine x. What happens with a double negative? Becomes positive, and I am left with sine x, which was my goal. Problem done. Okay? Question? Yes, it's at here. Oh, because I had a double negative? No, it became a positive. Right, because two negatives become a positive. Okay? Omar, did you get your question answered? Yeah. Good? Okay, please take a moment and try number 2 on your own. Okay, so we have 3 has pi. If you remember, if you can't remember where 3 has pi is, 3 times 180 is 540 divided by 2 is 270. So it would be right here, okay? Pi is worth 180, so 3 times 180 is 540 divided by 2 is 270. Okay? All right, so sine of 3 halves pi cosine x plus cosine of 3 halves pi sine x. Okay? What is the y value at 270? Negative 1. Okay, remember this ordered pair here is 0, comma, negative 1. Cosine, comma, sine. Okay? Plus, what's the cosine of that location? 0 times sine of x. Well, 0 times anything is 0, so that cancels. And that leaves me with negative cosine of x. Okay? Go ahead. Yes. How did I get negative 1? This dot here, what's the ordered pair for this dot? Negative 1 because it's down the y-axis instead of up. Good? Yes? Yes. Cosine is associated with x, sine is associated with y. And if you ever forget, alphabetically, cosine comes before sine. And that's why tangent is sine over cosine, because it's like slope, so y over x. Okay? Yes. Cosine is x, sine is y of an ordered pair. Good? All right, please try number 3. Okay, so I see a lot of you doing this the long way, which is fine. But before I sub anything out, I write it out to see if there's something that cancels so that I don't need to do extra work. So I'm going to start with this one right here, and that's going to be cosine 30 cosine x plus sine 30 sine x. Because it's cosine, I use the cosine formula. Remember, if you look at your formula sheet, cosine is crazy. So when I plug it into the formula, I do the opposite. Okay? My x always does something crazy opposite. If it said x plus 2, in parentheses, I really move to the left instead of the right. X is always opposite. And remember, when you're solving for x, you want to move x to the other side. You do the opposite, right? Okay, so I'm going to combine that with this one, which is cosine 30 cosine x minus sine 30 sine x. What do you notice? Oh, they cancel because they're the same but different signs. So let's go ahead and cancel them. How many cosine 30 cosine x's do I have? 2. 2 cosine 30 cosine x. Now I only have to substitute one time. Using the hand trick. The cosine of 30 is how much? Square root of 3 over 2 cosine of x. So let me ask you, what is 2 times the square root of 3 over 2? It is simply the square root of 3 and then the cosine x. Problem done. Okay? I would like you to try your best on 4, 5, and 6. I'm going to give you 6 minutes. I have a hard time drawing beta and alpha. So you can do B and you can do lowercase a, or you can do an X. Okay? Whatever works for you for number 4. Good? Okay. All right, here we go. Number 3. I did sine, beta, cosine, alpha, minus cosine, beta, sine, alpha, over sine, alpha, sine, beta. Okay, I have 2 parts in the numerator, so I can separate it out as long as I do what? Keep the denominator. So that gives me sine b cosine alpha sine alpha sine beta minus cosine beta sine alpha over, keeping the denominator, sine alpha sine beta. Okay, so I took this and put it over the denominator, okay? And then I took this and put it over the same denominator. I turned it into 2 separate fractions, okay? Now, what can you tell me, madam? Look at this fraction. What can I do with this fraction now? I can cancel out the sine beta. What is cosine over sine? Cotangent. So we have cotangent alpha minus, what happens over here? The sine alpha cancels, and it leaves me with cotangent beta. Good? Better? Okay. Can I move on to 5 or not yet? 5 and 6 are technically the same as problem number 3. It's just all variables, no numbers to switch out. You can only switch out radians, which will have a pi, or degrees. If it is a Greek variable or any other variable, you just keep it going. Good? Okay, number 5. Talk me through it. Cosine, hold on, I messed up already. Cosine alpha, cosine beta, minus sine alpha sine beta. Again, I like to do like systems of equations. And combining like terms. I'm going to write it below. cosine alpha, cosine beta, plus sine alpha, sine beta. What happens? The sine alpha, sine beta cancels because I have a positive and a negative of the same exact item, and I am adding. Okay, how many cosine A, cosine betas do I have? Two. Two cosine alpha, cosine beta, which matches, therefore I am done. Okay, does anyone need time for number 6? Need a little more time? Okay, 30 seconds and we'll. All right, number 6, same exact thing. Talk me through it. Sine alpha, cosine beta, plus cosine alpha, sine beta, plus sine alpha, cosine beta, minus cosine alpha, sine beta. What happens? Cosines cancel, leaving me with 2 sine alpha, cosine beta. There are 4 problems on the back, 7 through 10. They are your homework. Number 10, I tried to trick you, so look at it very carefully. Yes, ma'am, 7 through 10.